Today's lesson is on neutralization reactions, and neutralization is the word that we use for a reaction between an acid and a base. So you probably don't need me to explain why we call it that, but let's take a run through at what that looks like anyway. So when you mix an acid and a base, you're starting with something that has a low pH and something that has a high pH, and your products are going to have a pH somewhere in the middle. So one of the things that you're always going to get from this kind of reaction is water, and the other thing that you're going to get is an ionic compound, which is often referred to as a salt. Sometimes it could be the one that we actually call salt, but it also could just be any old ionic compound. So let's take a closer look at a couple of examples. So sort of the classic example is hydrochloric acid and sodium hydroxide. So you can tell that this is an acid because its formula starts with H, and you can tell that this is a base because its formula ends with OH. And this is just a double displacement reaction. So what's going to happen is the hydrogen ion from the acid is going to bond with the hydroxide ion off the base. And if you put those together, you could write that as HOH, but we are more likely to write it as H2O. And then the other product is going to be what you get when you combine the cation from the base with the anion off the acid. So in this case, that would be NaCl, the salt that we call salt. Now you need to make sure when you're writing the formula for that ionic compound that you're thinking about the charges on the ions for sodium and chloride, or whatever the ions would be, and you're making sure that you get them to balance. Let's do one more example together, and then I'll ask you to do one without me. So let's say that our acid is nitric acid, but our base is magnesium hydroxide. Okay, so one of our products will always be water, so we're going to go ahead and write that in. And again, that's what we get when we combine the hydroxide off the base with the hydrogen off the acid. Now, right now, it looks like we've lost out on some of our hydroxides, but in a minute, we'll go back and balance the equation and show that we are obeying the conservation of mass law here. Okay, now magnesium has a +2 charge, and nitrate has a -1 charge. And so when we put those together, the formula for our salt will be MgNO3 in parentheses 2, because it takes 2 nitrates to balance out the charge of that magnesium. Now, if you take a look at our equation, it looks like we have 2 nitrates on the product side and only 1 on the reactant side. So we're going to need a 2 here. And now we have 2 hydrogens and 2 hydroxides on the left. So that gives us 2 water molecules on the right. Okay, let's try this one. H2SO4 is our acid, and LiOH will be our base. So pause the video here and see if you can predict the products for this reaction. Okay, let's see how you did. So one of our products will be water, of course, and our other product will be lithium sulfate, and it has the formula Li2SO4, and that's because lithium has a +1 charge and sulfate has a -2 charge. And then to balance this equation, we need a 2 in front of the lithium hydroxide and a 2 in front of the water. So one of the things you have to be able to do is predict the products and balance the equations for the neutralization reactions. Hopefully you're feeling good about that. The second thing that we want you to be able to do is to do stoichiometric calculations involving acids and bases. So let's take a look at that next. Here's our balanced equation from that previous example, and let's use it to solve a stoichiometry problem. So let's imagine that we use 30 milliliters of a 0.25 molar H2SO4 solution to neutralize 22 milliliters of a lithium hydroxide solution, but we don't know its concentration, and that's what we want to find out. So this is a classic chemistry analytical process known as titration, and you're going to watch a video about that in just a few minutes. But for now, let's think about how we could solve this problem. So we could use this information, the volume and concentration of the H2SO4, to get to moles. And if we know the moles of H2SO4 that react, we can figure out the moles of lithium hydroxide that react. And once we know the moles of that react, we can use that and the volume to find our molarity. So this is a three-step problem where we're going to use some information to get to moles, then we're going to convert to moles of another thing, and then we're going to use that and some other information to get to our answer. So here we go. So the first thing that we want to do is change our volumes to liters because molarity is in moles per liter, and we want to make sure that our units are going to appropriately cancel. So I'm going to write down my given amount of H2SO4, but I'm going to write it down in liters, not in milliliters. So I have moved the decimal point 3 places to the left. Okay, those are liters of H2SO4 solution. So the next thing I'm going to do is put liters of H2SO4 below the bar and moles of H2SO4 above the bar. And I'm going to fill in how many moles there are in 1 liter. Well, molarity is the definition of it is how many moles there are in 1 liter. So our molarity here tells us there are 0.25 moles in every 1 liter. So now we're going to cancel those out. And if we solve the problem right now, we would know how many moles of H2SO4 there are. But instead of solving right now, what we're going to do is we're going to change moles of H2SO4 to moles of lithium hydroxide. So moles of H2SO4 below the bar and moles of lithium hydroxide above the bar. And here's where we're going to use the coefficients. So this is going to be a 2 and this is going to be a 1. And now our moles of H2SO4 will cancel out. So what we're trying to find is molarity, and that is moles of LiOH divided by liters of it. So if we solve right now, we will be at the moles of lithium hydroxide, and so that will go on the top of our fraction bar here, and then for liters, we will use 0.022 liters because that's the value given in the problem. So when I type in 0.03 times 0.25 times 2, I get 0.015, and those are moles of lithium hydroxide. So I'm going to put that here, and then I'm going to divide by 0.022. And when I do that, I get 0.68 molar, and that's our answer. Here's another question that's going to be a little bit similar, but a little bit different. So here's the equation from our second example between nitric acid and magnesium hydroxide. And let's say this time that we have 50 milliliters of a 0.1 molar HNO3 solution, and we are going to use a 0.25 molar magnesium hydroxide solution to neutralize it, and we want to know what volume of the magnesium hydroxide solution we would need. Okay, so we're going to start this just like we started the last one. So I'm going to change my liters, or my milliliters to liters of nitric acid. And I'm going to convert my liters of nitric acid to moles of nitric acid. And again, because it's moles over liters, I can use the molarity there, and that will make my liters cancel. Okay, now I'm going to convert to magnesium hydroxide because the question's asking about magnesium hydroxide. So I'm going to change moles of nitric acid to moles of magnesium hydroxide. And this is where I need the coefficients. So this time it's a 1 and a 2. And that will get my moles of nitric acid to cancel. Now in the last one, what we were trying to find is the molarity. So we need to divide the moles by the liters. But in this one, what we're trying to find is the volume. So I'm going to go just one more step. So I will change moles of magnesium hydroxide to liters of it. And again, I'm going to use the molarity there. But this time, notice it's liters on top and moles on the bottom. And you want to make sure that you get the numerical value of the molarity with the word moles because it's the moles in 1 liter. So now we're going to do 0.05 times 0.1 divided by 2 divided by 0.25. So when we type all of that into our calculators, we get 0.010 liters, or that would be 10 milliliters. And reporting the answer either way is fine.